So I think we are now at a good number, and we can start the presentation. So hello again to all of you joining today. I am pleased to introduce the publishing of Summer Outlook 2025. And in today's public webinar, we will present the main results coming out of the simulations. The report has already been published on the website and is accessible for all of you, including the input data as well as the country comments that all DSOs have left. And yeah, without further ado, we can go into the housekeeping rules. For this webinar, we will be recording it and also publishing it afterwards. You will ask questions, or you can ask questions directly through Slido. You have the QR code to join the Slido or the number to input on the Slido website over here. It would be great if you put your name and company details. In case we cannot get to answer your questions, we can come back to you later on that. And considering the time constraints, we would select the most upvoted questions if we do not have time to answer all of them. Without further ado, I will then pass it on to Simon Art to present to us the results of the Summer Outlook 2025.
Thank you, Alexandro. Hello, everybody. My name is Simon Art. I'm working for Swissgrid, and I'm here on behalf of ENTSO-E, convener of steering group seasonal outlook. So maybe just to get everybody on the same page around this product here that we are talking about. So the world of ENTSO-E outlooks is actually the TYNDP. It's used for policy decisions, also for identifying investment candidates. So it has a long time horizon, longer than 10 years, so maybe 2040, 2045. It's followed up by ERA, which is up to now. It's published every year. This looks on the generation side. It's about informing investment decision for generation capacity. It looks ahead 10 years, usually for some pivotal years. And then we already see the seasonal outlook. This is the one we're talking about today. Seasonal outlook is published 2 times a year, once for winter, looking at the coming winter and looking back on the last summer, and once for summer, looking forward to the next summer, to the coming summer, looking back on the past winter. And this is what we will talk about today. And this one is also followed, if we go more into, let's say, the operational realm and more into real time, is followed by week ahead adequacy assessments called a short-term adequacy assessments. These are done on a rolling basis on a 1 week horizon. And then it's needless to say that uncertainty is larger if the time horizon is longer. So thus being said, we can already go into the seasonal outlook. What we see here are the summer trends in available generation. We have a comparison summer 24 with summer 25, and we see a total increase in renewable energy sources capacity of 97 gigawatts, which is mainly driven by installed capacity in solar, making up for 89 gigawatts, and also by more capacity in wind, making up for 8 gigawatts. The increase in RES is accompanied by a total decrease in thermal, mainly driven by the decommissioning of hard coal, lignite, and oil. And in total, this is not completely balanced by the additional installation, of additional gas capacity of 12 gigawatts. So the total decrease in thermal is 7 gigawatts. It's not completely balanced by the additional gas capacity. I want to also draw your attention to not such a large bar on this graph, the batteries, because the batteries on a relative scale, they show the steepest increase. So the installed battery charging or discharging capacity increases from 11 to 25 gigawatt if we compare summer 24 and summer 25, which is the steepest increase on this slide. On a relative basis, it's 127% of more battery capacity. So having seen available generation, we can ask the question, how much of this generation is actually available and not on planned maintenance for this summer? And this is shown here. So this shows the planned availability, the planned unavailability of thermal units. Maybe it's good to say that the data are collected in February for the seasonal outlook. And we usually, and also this time, we provide a dedicated update window where TSOs can update the planned maintenance data. This update window closed end of March. So what we see here is March data. And these March data that we collect, they suggest that next week, so 5th of June is next week, actually, we see more or less 70 gigawatt of thermal units on planned maintenance, or unavailable in a planned manner. This planned unavailability drops towards midsummer to roughly 40-45 gigawatt, and it increases again and peaking at 55 gigawatt towards the end of summer, where the highest shares of unavailability is nuclear unavailability. And this already brings us to the overview of the adequacy results. So at the first, maybe more, it's important first to say that we do this exercise 2 times. We simulate assuming normal market conditions, market-based dispatch, and we get a first result. And after that, we perform the same simulations, considering non-market resources. And then we can assess where non-market resources actually are able to mitigate the risk. So if we look at the left graph, at the left map, we can see that we observe adequacy risks in Northern Ireland, in Ireland, in Malta, and in Cyprus, indicated by the turquoise color, and also indicated by yellow dots, which are sometimes very, very tiny because they are very, very small, so we can hardly see them. But it shows the relative EENS, so the relative expected energy not served relative to the consumption during the season of the respective bidding zone. Considering non-market resources, we see that the risk is completely mitigated for the case of Northern Ireland. It can be reduced, substantially reduced, for Ireland and also for Malta. However, for Cyprus, the risk pertains and should be continuously monitored by TSOs and regional coordination centers. If we go a bit into the details of the adequacy result, what we see here is the weekly loss of load probability for the four bidding zones where adequacy risks were identified. So we can see that in the case of Cyprus, the seasonal EENS, which is shown in absolute numbers on the right side, actually stays more or less, stays the same. So it should be closely monitored. And of course, this is also a result of the fact that Cyprus is an isolated system as of now. Great Sea interconnector is planned between Crete and Cyprus, but will not be built before 2028, according to public sources. The case for Ireland, Malta, and UK Northern Ireland is actually a combination of high planned outages of aging thermal units with wind reliance. And this is also why they have to rely on non-market resources. In the case of Cyprus, it's also high planned outages combined with unfavorable weather conditions, such as a high load combined with low renewable energy sources output. As far as I remember, this is actually it from my side. Yes, I'm happy to pass over to Sarah, who will talk to us about renewables excess generation.
Yes, thank you, Simon. So hello, everyone, also from my side. My name is Sarah Mendel, and I'm also part of ENTSO-E. So yeah, let's continue with the next slide, the next topic. So to improve this study, we developed an additional insight, which is now implemented for the first time in the summer outlook for 2025. It is an analysis on excess generation from variable renewable sources. So we're talking about wind and solar, coming out of the market modeling optimization. I want to highlight that these numbers are affected by limitations and assumptions in the model itself. So we do consider interconnection between bidding zones as well as must runs or inelastic constraints from convenient power plants. But what we don't consider are grid constraints within our bidding zones, as well as ramping constraints for thermal generators. So as a conclusion, the result is not a forecast of renewable curtailment and should therefore not be interpreted as one. Then maybe we can go to the next slide. Let's have a look at the results. For this analysis, we developed two plots, a box plot you can see on the right side and a heat map on the left side. Just note that for this presentation, we shortened the plots a bit and only show the bidding zones that show excess energy. But the final report, of course, includes all the bidding zones. Let's start with the box plot on the right. The box plot shows the variation of the absolute number of unused renewable energy over all different weather scenarios. So for each region, we have a box with whiskers. The whiskers can be or should be interpreted as minimum and maximum values. The edges of each box represents the 25th percentile and the 75th percentile. And then the line represents the median and the black dot depicts the average out of all the values. We also have an additional column on the left side of the box plot. It shows the average excess factors over the season, so relative to the total amount of produced energy per bidding zones across all weather scenarios. While the box plot shows seasonal values, the heat map on the left allows a bit more insights into the season by showing the average excess factors, so the relative values in a weekly resolution over the summer season. Here we also added the average number of hours that show excess energy per bidding zones as additional information in form of a column again on the left side. That's basically it from my side, so I would hand over back.
Thank you, Sarah.
Yes, and with this, we come to the last slide and to the end of our meeting or the presentation. The report publication has been indeed done today, and there is, of course, a continuous week ahead monitoring through the regional coordination centers to to ensure the adequacy of the system for the coming summer. So thank you very much for listening, and the floor is now for the attendees to ask questions. So we can give a few seconds. Move back to the slide where it's clearly visible how to join on Slido, just for the members to have an easier access. So for the moment, I see no questions, which I take as a sign that everything was very clear. We will still be here for a couple of minutes in case anyone is typing right now. So I see a question from an anonymous typer asking what are the main reasons for the adequacy risk that we see in Ireland? So to answer the question about Ireland, I would say, first of all, of course, being a scarcely interconnected island compared to the rest of Europe plays into the picture. But the main reasons are usually reliance on old thermal units, as well as a reliance on wind generation, which is, of course, variable, as well as in moments where we have high forced outages, so unplanned outages of the power plants. Our simulations go through 20 forced outage sample, as well as 36 weather scenarios, which means that we have a high number of variability in how the units stay in the market and also on the weather conditions. And in a very limited number of them, we see some adequacy risks in Ireland. I see another question from Simon from Coreso, whether we have any recommendations of actions from ENTSO-E following the summer outlook report. I think from ENTSO-E's part, when we see these adequacy risks in countries, we immediately reach out to the TSOs and we make sure that these risks are also something that they are aware of or that they share. Then, of course, as we discussed, we are also coordinating with regional coordination centers. But I would leave it to Simon if he wants to add anything to that.
don't have nothing to add. Thank you.
We also have a question asking whether Ukraine has been investigated. The situation at the moment with Ukraine is highly unpredictable, and there is a qualitative message on the system in Ukraine and Moldova in the summer outlook report. However, due to this sensitivity of the situation, we do not have official results as well as input data release from Ukraine. But we are in touch with them internally. And then one more question on whether it has been possible to validate the results of the renewable curtailment calculated in the Plexus model and showed in the report. So we have done some very limited validation of the results with a couple of TSOs, but we already know that these results are not entirely accurate for some of the bidding zones. The constraints that we have highlighted, such as the transmission, not having a national transmission and distribution grid, not having ramping constraints, impact certain bidding zones more than others. So this is why we say that this is not a forecast of the curtailment of renewables, and it does not represent the real world situation. But nevertheless, it does give an indication on what this generational excess would look like in a more ideal market simulation. So I see that there are no further questions on Slido. And I think at this moment we can close the call. I would suggest to anyone who still has any further inquiries to reach out to ENTSO-E, to myself. And I wish you all a very good rest of the day then. And thank you very much to Simon and Sarah for joining today and for presenting and for the work done throughout these months.
Thank you to you too.
Thank you. Bye-bye.
Goodbye.